We welcome you all on behalf of NISM. Now, I would like to request Dr. CKG Nair, Director NISM, to please welcome and felicitate Dr. Viral Acharya with a flower bouquet. Now, I request Dr. Kevin James to please welcome and felicitate Mr. Amish Mehta with a flower bouquet.
Every auspicious occasion requires an auspicious beginning. So we would like to begin the ceremony by lighting a lamp. Light is considered as a symbol of auspiciousness, prosperity, and abundance. Light brings brightness with it and removes the darkness. Light makes it possible to see things clearly and to gain knowledge. I invite all the dignitaries to please do the honors. I request all of you present to please rise up and for the Saraswati Vandana.
कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रान्विता या वीणां वरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्करप्रभृतिभिः देवैः सदा पूजिता सा मां पातु सरस्वती भगवती निशेषजाड्यापहा.
Thanks to all the dignitaries. I request all the guests, participants, and dignitaries to please take your seats. Thank you. Well, Albert Einstein said, if I knew what it was we were doing, it would not be called research, would it? It is on occasion like this we get opportunities to test our knowledge and understanding. We look forward to get an exposure about what the best of the brains think about this very dynamic role of capital markets in sustainable growth of economy.
May I now invite Dr. CKG Nair to render his welcome address for the conference. Dr. Nair assumed charge as Director NISM on 28 September 2021. Dr. Nair was a member of the Securities Appellate Tribunal during 2016 to 21. Before joining the SAT, he was an officer of the Indian Economic Services for about 31 years and held various positions in the Government of India, such as Director of Development Policy, Director of Capital Markets, to name a few. He was involved in substantive policy law institutional reforms in the financial sector in various capacities. He has been a member of several committees, working groups, task forces dealing with various issues in the financial sector. He has also been writing articles on topical financial sector issues. Sir, I request you to please deliver the welcome address.
Good morning and a very warm welcome to NISM as well as to the third International Capital Market Conference. The weather in Padalganga is not as cool as we expected. We apologize for that, but I am sure the conference proceedings will make it quite cool as we go ahead. This year, the conference has been organized by NISM jointly with the Systemic Risk Center of the London School of Economics. We are indeed grateful to the LSE SRC for supporting in designing and organizing this conference. We particularly appreciate the role played by Dr. Kevin James and Dr. Amil Dasgupta from the London School of Economics. Dr. Kevin James is present already with us, and Dr. Dasgupta will be joining during the course of the events. This annual capital market conference series is financially supported by an endowment from the SBI, a banker to almost every Indian, which is their title in the advertisement. They claim that it's a banker to every Indian, but I have just slightly modified it. We are indeed grateful to the SBI for their support in this endeavor. The main theme of this two-day conference is role of capital markets for sustainable growth of the economy. Per se, this topic is not new, and several conferences and seminars have been held with this theme. However, the twist in the tail, with whatever spelling you want to put there or an emoji to the word tail, is sustainability. Because the issue of sustainability is the latest, which the entire world is discussing and debating. The Conference of Parties of the UNFCCC has only recently gathered with a bang in Egypt and ended the conference with just a whimper. And so we thought probably the big climate change and environmental sustainability conferences are not adding much value apart from raising the temperature locally instead of reducing it. So we thought it probably micro events like ours may help in coming out with more durable and sustainable solution to the issue of sustainability. In addition to the issue of sustainability, of course, we have a number of sub-themes relating to the financial sector. Some of them are new, some of them are old themes, and we have experts talking on all these themes. In addition, we have 20 technical papers accepted through a rigorous blind review process by a number of experts who helped us in doing that. So the technical paper presentation session will provide an opportunity to look at the academic research outcomes that are dealing with the sub-themes like sustainable capital market investments, linkages between real economy and financial markets, quality and adequacy of disclosures and data for valuations, etc. And valuation, as you are aware, is one of the big issues confronting all the financial market jurisdictions in the world. In this inaugural session, we have two eminent experts, Professor Viral Acharya and Mr. Amish Mehta, speaking to us. A formal introduction will follow, but just to flag about their importance, Professor Acharya, as many of you know, is a prominent voice on important discourses on financial stability, monetary policy. He was Deputy Governor in the Reserve Bank of India. Environmental issues, which he is going to talk today on pricing of physical climate risk is basically what he is going to address. So we are very happy that in addition to his regular position as CV Star Professor in the Stern School of New York University, he is a visiting professor with NISM. So we indeed welcome you, and we are grateful that you could join in time, traveling all the way from New York. And he reached only yesterday in Mumbai. Mr. Amish Mehta is currently MD and CEO of CRISIL, and he is also following, in addition to playing the role of a gatekeeper to the financial sector in terms of rating all the doubtful instruments or securities. He is an avid follower of the sustainability issue. Early this year, CRISIL, under his leadership, brought out a CRISIL Sustainability Yearbook, which explored the theme of what is on the ground by the corporate India, the main companies, and in promoting sustainability and what is the outcome. I'm sure he will be sharing some of those thoughts in his address. We are indeed grateful, Mr. Mehta, for taking time out to travel to Padalganga and come here. As we proceed with the conference, we will again hear certain important voices from experts like Dr. Zachariah Sortner, who is Professor of Finance, Frankfurt School of Finance and Management. He will be talking to us on the methodology and measures for ESG scores, an important indicator because ESG financing has become an important area, and and there are lots of doubts about the sustainability of that financing model itself. So a correct perspective on scoring ESG measures itself will be a first step in having a sustainable financial uh, sector or subsector for sustainability itself. And tomorrow we will have a panel discussion on the growth of asset management and its impact. Mr. Amarjit Singh, Executive Director of SEBI, and Professor Amil Dasgupta from the London School of Economics will take us through the nuances and the latest development in this on this important topic. In addition, we have other presentations of all the 20 papers accepted. And we, in fact, received 147 papers in all. As I already mentioned, through a rigorous blind review process involving 62 experts. We are indeed grateful to all those experts who helped us in shortlisting the papers. We have accepted 20 papers, which some of them which actually bring out a lot of methodological innovations and certain findings as well, which we will go through when they present their papers, and we will have an idea about the new frontiers in which people are researching on this area. While we are on this research agenda and involving the accepted papers, I have a thought on financial sector research. Research on complex financial sector or financial systems, or chaos as some of you may like to put it, and I would of course like to put it as chaos rather than systems, should be capable of giving some sort of forward guidance, not only on markets, as mostly the case now. Everybody researches on what is going to be the market tomorrow, market for particular security or securities market in general, or indices or commodities, all those things. Though they themselves claim that you can't time the market, but most of the research right now is on how to time the market, or how to invest in accordance with some idea on timing the market. But what I am talking is that the research, substantive research, should guide us on possible trajectories of innovations in products, processes, and behavior changes. With revolutionary changes in the financial sector, with technology playing the leading jugalbandi partner, market is front-loading us with all the surprises through their research, which is basically marketing. Research should help in anticipating at least some of these major themes on the frontiers, so that regulators, policymakers, and market participants are prepared to face both the categories of innovations, the benign and the malignant, the benevolent and the Frankenstein. I hope the papers being presented here will send some light on the shape of the tech fin, which is right now we are in the era of fintech, but shortly we will be getting into the tech fin mood, which is unfolded at great speed. After the technical presentations, of course, we have the valedictory session where Mr. Ajit Balakrishnan, founder chairman of Rediff.com, and Professor Banamurthy, Vice Chancellor of Baba Sahib Ambedkar School of Economics, University in Bangalore, will be talking to us, in addition to giving away the awards for the best papers, etc. And while talking of the papers accepted for publications, our team have actually put in place arrangements for publication. We have tied up with 5 leading journals, which are referred journals. Some of them will bring out special editions, and some will be publishing some papers as part of their regular editions. Before I part with, I should be thanking all the members of the jury, who included Mr. Ajit Balakrishnan, Dr. Banamurthy, Dr. Malaviga Dio, Dr. Kevin James, with Professor Latachari coordinating that. List of chairs, which included Dr. Tirthankar Patnaik, Dr. H.K. Pradhan, and many of the internal faculty. and a list of discussions which runs into a number of them. And I take this opportunity to welcome them, as well as to express our sincere gratitude to uh, take up the responsibility of chairing and as jury members and as discussants, in addition to some of them reviewing the papers as well, which were accepted for the presentation. I am also grateful to all the faculty of NISM, with special thanks to Professor Ladachari, who coordinated the entire effort, and department heads and all other staff in contributing to both the intellectual exercises and in making a wonderful support arrangement to make this two-day event comfortable for all of us. I also appreciate the role of our students who played in helping in organizing the conference, as well as in providing us a lot of support facilities as we go forward. They all have played multiple roles, and thanks to all of them. Once again, I welcome all of you, or each one of you, in attending this conference and seeking your full support in making this two-day event intellectually stimulating and a successful one. Thank you very much.
Thank you so much, sir, for your warm welcome address and for beautifully elucidating the role of research to promote sustainability in our economy.
Now it's time for the keynote address for the conference by Dr. Viral Acharya. Mr. Viral Acharya is the CV Star Professor of Economics in the Department of Finance at New York University Stern School of Business. He was the Deputy Governor at the Reserve Bank of India from January 2017 to July 2019, in charge of monetary policy, financial markets, financial stability, and research. He has been an academic advisor to the Federal Reserve Banks of Chicago, Cleveland, New York, and Philadelphia, and provided academic expert service to the Bank for International Settlements, IMF, and the World Bank. His primary research interest is in theoretical and empirical analysis of systemic risk of the financial sector. Sir, I request you to please deliver your keynote address.
Great. Thank you so much. Very good morning to everyone. Thank you, sir, and thank you, Kevin, for putting together this conference and inviting me. This joint work with Tim Johnson, Suresh Sundaresan, and Thomas Tominen. And the question we are asking is physical climate risk priced in asset markets, in prices of securities, etc.? For most of us, perhaps all of us, the first exposure to climate risk was probably through the term global warming, that the planet is actually warming up at a faster pace than we had thought because of various kinds of emissions, etc., that are taking place. And physical climate risk is the risk that by being situated in a particular geography or region, you are exposed to such shifts of climate that are taking place. So, for example, if you are in a very hot region that's getting even hotter, so take New Delhi, for example, I would say New Delhi has a physical climate risk, which is that it's exposed to the risk of heat stress. For some other regions, of course, global warming could be a benefit. The city of Chicago, for example, is actually having more pleasant temperatures than it used to as a result of global warming. So global warming need not be necessarily bad news for every single geography, but we think it is bad news for the planet as a whole. But importantly, there's some regional variation in the exposure. And this is exactly the example I was giving. You can, if you want, you can take New Delhi versus, I don't know, Ladakh. And, they would be very differently exposed to heat stress. So the idea of the paper is that now if you look at securities that are issued by, say, municipalities in Chicago versus a municipality in Delhi, just in the hypothetical example, would Delhi have to pay a little bit extra cost of borrowing, all else equal, simply because it is exposed to the risk that higher heat stress will lead to some losses to the municipality and the businesses which are there. You can then ask the question, what about businesses? Maybe some businesses are primarily working out of Chicago, some are working out of New Delhi. Would the businesses in New Delhi be perceived, all else equal, by markets as being more vulnerable because, in certain periods of extreme heat, they will have low worker productivity, very high energy expenditures because of air conditioning, etc., that they have to use. And maybe the city will simply shut down for some days of the summer altogether. Will the company that is headquartered in New Delhi then have to pay a higher cost of borrowing compared to an all else equal company in Chicago? And then you can ask the same question on equities. Will the companies have to offer a higher rate of return to shareholders given that they are exposed to more heat stress risk as a result of this? Now, heat stress is just one of the many physical climate risks. If you're in United States, then the one that gets talked more about is actually the risk of hurricanes. Hurricanes are very salient when they happen, the way they happened in Florida this year, or the way Hurricane Katrina hit the city of New Orleans and the neighborhoods about 15 years back. It's very salient. The damage is right in front of you. Entire townships get sort of destroyed altogether. But it turns out heat waves can also actually be quite damaging, even though their damage is not necessarily as visual as the damage from hurricanes or cyclones is. So I'll mainly talk about heat stress, but keep in mind that there are these other physical climate risks that one may have to worry about. And it's possible that these risks are related, which is that maybe it is the risk of extreme heat which causes certain kinds of evaporations and other dynamics to take hold, which then might be aggravating the risk of hurricanes and so on. So, first things first, I just wanted to explain to you why heat waves matter in terms of economic damages. So, here are some estimates. Focus on the plot that's on the left. It shows the heat wave damages estimated in the US per year. These are contributed by energy expenditures, low labor productivity in high-risk industries such as mining, construction, farming, forestry, and fishing, etc., where you have to be exposed to the physical risk of being out there. But there is also lower productivity in low-risk industries, maybe somewhat less so than in high-risk industries, but even maybe other than working from home, even a financial sector analyst might struggle going to work and coming back on very hot days. Now, these numbers are very large. Just the energy expenditures for the US due to the heat waves are estimated on the average of about $100 to $125 billion per year. These calculations are from a paper in Science. And as I was saying, even though other physical risks are important, hurricanes and sea level rise, they are somewhat isolated problems. Not all regions are exposed to hurricanes. Sea level rise is primarily an issue for coastal areas, not for the inland areas. And so when you aggregate it up across the country as a whole, these other damages don't amount to being as large as $1 billion per year. Just to make this a little more tangible, here's one example of the fact that heat stress or heat waves are picking up importance. California wants to sensitize its citizens more to the risk of heat waves so that they evacuate in a timely manner from the times when heat waves occur. So just the way hurricanes are named, like Hurricane Ian or Hurricane Katrina or Hurricane Sandy, California is debating whether to give names to heat waves in order to make it salient in people's minds that certain heat waves are coming. Another example that I didn't talk about, there are, of course, other damages that are linked to heat waves. There are still nuclear power plants in different parts of the world. They have to be maintained and at certain levels of cool temperatures. If temperatures get warmer, it'll either become very, very expensive to keep them cool, or they would have to not be operated in certain times and parts of the day. So the power capacity of certain sources of energy could also be impacted. In California, which perhaps in US, along with maybe states like Oregon, Arizona, Nevada, New Mexico, is the most exposed to very severe heat waves. What are severe heat waves? Maybe for us it's not as extreme, but these are temperatures on the order of 35 degrees Celsius or plus. In Arizona, even 40, 45, so 115 Fahrenheit, 120 Fahrenheit. Uh, these are the kinds of heat waves that we are talking about. At least in United States, when the temperatures go beyond 100 Fahrenheit, they find a very significant impact on worker productivity in those states. It's just that maybe in India, we are conditioned to living with that level of worker productivity being low precisely because our temperatures are so high at times. But in California, there's already been a climate change bankruptcy, which is of this utility PG and E. And what is very interesting is that almost institutionalizing a low labor productivity when temperatures are high, the state of Oregon is contemplating that it's going to require that employers protect outdoor workers from heat and wildfire smoke. They're going to actually build it into the law that you can't have more than certain number of hours per week or create conditions which are conducive to working when temperatures actually become very, very high. So I think in a way this is quite a severe problem, and I'll try and explain how we are getting at this issue, but at a very high level of findings. What we show is that if these heat waves are going to contribute an extra 1% of GDP loss to a municipality, it will increase its cost of borrowing on average by 15 basis points per annum. So if the variation is about 5% of GDP in the cross section of municipalities, the costs of borrowing could vary by about 75 basis points. So in some sense, it's saying that it's a source of credit risk. That going forward, markets are already pricing in that municipalities which are in hotter climates will have to actually pay higher costs of borrowing because they're more likely to suffer losses and default on their bonds. The same way in corporate bond spreads, I'll show you what the measure is. It's from a company called 427. But if the rank of an S&P 500 company on heat exposure is higher by sort of one standard deviation, it pays about extra 40 basis points per annum. And in case of expected returns on stocks, they have to pay extra 0.45 percentage points per annum again for issuing equity in the markets. So this is basically saying that heat stress is already being priced by capital markets as saying, if you're exposed to this form of physical risk, investors are saying you have to pay us an extra premium, because your cash flows are going to be more variable. And why are investors charging an extra premium? Because imagine the following scenario. Suppose the world becomes very, very hot. Investors will already be losing money in that state of the world because many companies and workers won't be able to produce at high levels of efficiency. So if you're holding a company in your portfolio in such a state of the global economy, and this company or the municipality will itself generate lower cash flows, that's an extra risk for you. As in the example I was giving, I would rather hold a bond of Chicago than a bond of New Delhi, and I will favor the bond of Chicago with a lower cost of capital as a result of this differential exposure to physical heat stress risk. Okay. I think I'll show this a little bit later, but just to make it precise. So one thing that's interesting about the pricing of heat stress risk is that it's more recent. It seems to be priced in the data more since 2012, 2013. There could be several reasons for this. One could be that investors are more aware that these risks matter, so there might be a greater awareness and attention to climate stress risk. Another possibility is that heat stress is actually increasing over time. as a trend, and maybe that's the reason why the market is now pricing it. The idea being that it was always being priced, but heat stress was very small. And so what I'm now finding as 40 basis points in corporate bond spreads was much lower at just 5 or 10 basis points. And so you could not statistically detect it. But now with increasing heat stress risk, the market is charging higher and higher total premium for bearing this risk out there. Okay, so the main thing I want to explain to you is this one technology or climate scientist method from a paper in Science, which I find very fascinating. And if nothing else, if I've been able to convey to you how that works, I think it would be very useful. I think someone needs to implement that for India using the methods that they have, or maybe climate scientists in India are already doing this perhaps. Okay. So what is this model? This model is called Sea Glass. It's, as I said, from a paper in Science 2017 by Seng et al., a range of a whole number of climate scientists. They basically looked at about 44 different papers in climate science, which are focused on modeling how are temperatures likely to evolve for the planet as a whole. And if I give you a particular global warming scenario for the planet as a whole, what is likely to be the distribution of temperatures in a given city as a function of that global warming scenario? Okay, so think about it as the following, which is that there's a global scenario, then you have to go from global to local scenario, and of course there is some noise associated with that. So every time the planet heats up, it's not guaranteed that Delhi will be at one particular temperature. You know, there is some noise or a distribution of temperatures that are possible in Delhi. Delhi's temperatures will rise as a whole, but there is still some distribution or uncertainty around where the temperature will be in a particular global scenario. So this model is called Spatial Empirical Adaptive Global to Local Assessment Systems. And the way it works is that they basically project, as I said, a particular global scenario, and then they use this different climate scientist models of projecting the global scenario into a local distribution of temperatures at a particular county or municipality. Okay. Now, what is this global scenario? There can be many global warming scenarios. In climate science, these are called RCP scenarios. So let me make this very concrete. So an RCP in climate science is a representative concentration pathway. Okay, what does that mean? So the scenario 8.5, which is at the top over there, is basically a path of temperatures from now, in this case, when they wrote the paper in, say, in 2013, from there until 2100. What is this 8.5? 8.5 corresponds to an average of 8.5 watts per square meter of carbon emissions or carbon concentration across the planet. That's the average concentration of carbon across the planet. Now, that's talking about global warming in a carbon space. If you want to convert that into temperatures, the climate science models would say that that's going to make the planet warmer by 3.2 to 5.4 degrees Celsius on average. Okay, that's the climate scenario. It's a very stressed scenario because most people think even 1.5 or 2.5 percentage 1.5 or 2.5 degrees Celsius average heating of the planet is already a very extreme scenario. So RCP 8.5 is a very extreme stress scenario. I'll try and explain why it makes sense to pick an extreme stress scenario very shortly. But essentially, this pathway is a pathway going from today, which is, as you can see, is at a much lower level of emissions, and increasing and gradually building up towards that extreme pathway. Okay, so now, so for each, so there are other concentration pathways. There's an RCP 6 scenario, there's an RCP 4.5 scenario. All of these map into different degrees of warming up of the global planet over the next 85 years or so. Then you need to convert that scenario first into a local temperature distribution, and then you need to convert the local temperature distribution into economic damages. Okay, so this local increase in temperature is basically like a dose of disease, and then you have to convert that into how the system will respond to that disease, which is, how much energy will it consume, how much will the productivity of the labor decrease, and that's the response function of each county or a municipality to that dose of heat wave hazard that it's going to be subject to. And they divide up industries, as I told you, into high risk and low risk industries and so on. Okay, so let me make this very concrete, and this is what I find the most exciting about this method, which is that, so let's take here two cities. One is Orlando in Florida, and the other is Miami in Florida. And the blue distribution that you see is the distribution of temperatures in degree Fahrenheit, which is the baseline in 2012. Okay, so that's the realized temperatures in 2012. Now, under RCP 8.5 scenario materializing between somewhere during 2080 to 2099, the distribution of temperatures for both Orlando and Miami will shift to the right. Okay, and that's in this orange bar. Okay, so this is what climate scientists do when they are basically projecting heat scenario for the planet. They take a scenario for the planet, and then using very localized models, they tell you that Orlando's temperature distribution is likely to shift in this manner if the planet as a whole is warming up between 3.6 to 5.2 degrees Celsius, as under the RCP 8.5 scenario. Now, you can see that there's a vertical line at 100. That's just a rule of thumb, which is that you calculate as to construct an index of physical heat exposure of a city. You ask the question under a simulated stress scenario for that city, how many days in a year will be above 100 degree Fahrenheit? Because that's the frequency of the year in which the productivity of labor is going to go down, the energy expenditures will rise, and so on. So basically, they calculate a measure called delta projected hot days, which is how many hot days will increase from the baseline scenario to this extreme scenario. Now, you can see that more or less neither of the cities has too extreme a baseline scenario now. So most delta projected hot days are coming because of global warming, and Orlando is going to be much hotter as a city than Miami. So the question then we are asking is Orlando's cost of borrowing through municipal bonds higher than that of Miami because it has delta projected hot days which are higher, for example. Okay, here's another example. This is Phoenix, Arizona versus San Diego in California. Phoenix, Arizona, you can see even in the blue bar is already very, very hot. It has many days, even in 2012, which are to the right of 100 degree Fahrenheit. But of course, under global warming, that temperature shifts further to the right. In contrast, San Diego, California is basically not exposed to global warming right now, but it is still exposed to heat wave risk in the sense that if global warming was to take the form of RCP 8.5 scenario in future, San Diego will also start having higher than 100 degree Fahrenheit days. Okay. Now, this is an important point, which is that in stress tests, you have to pick a scenario that is adequately stressed. Otherwise, you will conclude that San Diego has no heat stress risk at all. Okay. And this is important. So if you're doing a bank stress test and you say, let's assume a world in which stock market is booming, housing market is booming, then no bank will show any stress. Okay. Now, so that's not very useful. What's more important, it will not help you distinguish between banks at all because no losses are materializing in the first place. The same way, when you do climate stress scenario, you have to pick an extreme enough scenario because that's the only way you can distinguish San Diego from Miami, because otherwise neither of them will have any hot days at all. So how do you know which of these cities is exposed more to heat stress? Okay, so that's the reason why RCP 8.5 is picked as a stress scenario. even though it is not the more plausible scenario. The more plausible scenario may be RCP 1.5 or 2.5 or something like that. Okay. Okay, so then you can construct this delta projected hot days, and then this C-glass, which is the science paper method, it then uses some papers in economics from energy consumption of how much energy gets consumed in what city at what temperatures. It uses some labor economics papers to figure out the decline in the productivity of labor in a particular city as a function of the temperature in that city. Using some energy consumption data and this labor economics paper. And then you can convert this distribution that you have for a city into an economic damages number, okay, which is, so for example, in case of Orlando, when you go from the baseline 2012 scenario to the climate change stress scenario of RCP 8.5, it increases energy expenditures by 13.8%. Labor productivity decreases by 2.5% in high risk industries and by 0.5% in low risk industries. Okay, so this is a very important step because it says that ultimately I'm not interested in just temperatures. I want to know what is going to happen to securities. To know what's going to happen to securities issued by Orlando, I need to know what's going to happen to the cash flows of that municipality. To do that, I need to convert the temperature distribution into an economic magnitude of some sort. Now, why do all these things impact Orlando? Because energy is generally provided by utilities. Utilities don't pass through the full costs of production. When energy demands increase, they absorb some of the losses and pass them on to municipalities. And if labor productivity decreases, there will be less taxes collected by the municipality, and that will also add to the credit risk of the municipality. So that's the chain of connections that's happening from the global warming scenario all the way to the cash flows that will be available to pay the securities or the municipal bonds of this company. So, that's roughly the measure. Now, that's a very sort of granular measure that you can feel and touch. There are also scores available in the industry. So, a company called 427, which does some kind of climate science exercise of this type of its own, they sell scores of, like, just like you get a credit rating from SIR, you can get a heat score for different municipalities from this company called 427. They'll tell you, based on a company's locations in different regions and those locations' exposure to regional stress, they'll tell you that its heat score is 90 or 45. So they'll tell me for a company or a municipality what is its heat score. Now, what's the problem with a score? Ultimately, you have to map that score into some cash flow risk, and that is an extra layer of step that the company 427 doesn't provide. Okay, but in order to take the C-glass measure to a company, because a company is more complex than a municipality, a company will have headquarters and locations or plants, offices in different geographies. So you now have to convert this heat stress measure, which is at county level, you have to aggregate it into a total heat stress exposure of a company. To do that, you need to know its exact geographic exposure through sales or employees or capital in different locations, and that's a more complicated exercise. The company 427 does it for you in part, but if you have the granular data, you can do it yourself as well. Okay. So to just give you a heat stress map of the United States, this is what it looks like. On the left is the C-glass measure in terms of percentage damage of GDP, and on the right-hand side, it's the 427 heat score. They are not perfectly correlated. The 427 score puts a little bit of extra weight on the farmland belt of the United States, which is sort of all that Midwest patch. Whereas the C-glass measure attributes highest damages from heat wave more to places like Texas and New Mexico and so on, which are at the bottom. Now, one thing that's also quite important about heat damages is that you can see that this is a very slow moving risk in the geography, okay, which is that two adjacent counties have very similar heat stress risk to each other. This is very different from a score like a sea level score. So when sea level is rising, either you are exposed to it because you are in the coastal region, or you are not exposed to it because you are inland. So if you see on the right hand side, that physical risk is is very fast moving across geographies, okay, which is, and therefore it will be very easy to adapt to the risk of sea level rise. All that we have to do is not be on the coastal areas, we have to move inland in order to not be exposed to the risk of a sea level rise. In contrast, if you see on the left, it's not that easy to just move a few counties inside and be away from that risk. You'd have to go all the way into that patch on the left where perhaps the heat score is not very high, or to the patch in the northeast where the heat score is not that high. Okay, so that makes it much harder. So a question that always gets asked is, but Alaska will be a beneficiary of heat stress. Canada will be a beneficiary of heat stress. But that means to adapt to heat stress, the whole world will have to move to Alaska or Canada. Okay, and that's a much harder adaptation to do than to just say, I won't live on the coastal areas in Florida. Let me just move a little bit inside. That's a much easier adaptation to do. This is one reason why we think that heat stress may be the most important physical risk that we have to worry about. Okay, I want to show you one thing about India before I just maybe spend a little bit of time showing you the quick results, which is that the question is, does this matter for India? Whenever one thinks of physical risks in India, the risk I have heard the most about is the risk of groundwater sort of becoming not as easily available. I apologize for the map being sort of the Western map of India and not the sort of the map that we would like to see. But you can see here that if you look at the heat wave is again sort of, the stress is again red hot areas. These are different summers. This is the summer of 2004, which was relatively mild. Then you go to 2010, you can see that there are many regions which are very exposed to drought risk because of the summer. Then you see 2016, and then you see 2022 there on the right. And you can see that this is the sort of exercise that you can do now. This is done sort of using some data from Google and combining it with some temperature data in the past. But in principle, you can do sea glass kind of models and project what will be the temperatures in different cities of India under the RCP 8.5 scenario, and then what kind of economic damages, energy consumption, etc. that we are talking about. I haven't done that, but I think it would be a very interesting thing to do for India. But then heat stress could compound with other sources of risk, such as groundwater risk and so on. Of course, one reason why the groundwater risk is manifesting in the states you see is because that is also the very heavy farming belt of India, and they are digging very deep in order to bring water for irrigation and so on. Punjab, which has shifted from sort of wheat to paddy in a substantial way, is of course boring deeper and deeper because paddy requires more water than wheat does, and that's part of Punjab's groundwater problems if summers were to become hotter and hotter in India. So I just wanted to make tangible what does this mean for India. Okay, so just going back, I'll now just speed up on the rest of the presentation. So we basically we exploit one property of credit ratings which might change in future, but historically has been important, which is that that credit rating agencies explicitly say that as of now, they are not taking account of physical climate risk in order to give credit ratings. Okay, and why are they saying that? They say that for something to enter our credit risk models, we need to have great confidence in our ability to model it and track it in historical data, and that right now we don't have sufficient clarity on the evolution of physical risks in order to do that. Now, why is this important? Because if I'm comparing, say, Orlando's borrowing cost to Miami's borrowing costs, I can't just conclude that the difference in the cost of borrowing is because of heat stress risk, because they may have different credit risks because of other reasons. Maybe one's county is borrowing more than the other county. One county has a more rich population living in there compared to the other county. It collects maybe higher taxes for a variety of reasons. Maybe one is having a housing boom, whereas the other is not, and so on. So how do you control for the credit risk? We are going to rely on credit ratings. And why is that useful? Because as per credit ratings' own acknowledgement, controlling for credit ratings won't be soaking up the heat stress risk, because they are actually not factoring that in while constructing the credit ratings right now. Okay, so there are two steps. One is to control for credit risk that's not related to heat stress risk using credit ratings. And second, then there's a hypothesis that the market, however, is sophisticated to know that heat stress does impact cash flows. It does deteriorate the credit quality, even if rating agencies may not be factoring it in. And therefore, markets will charge a higher credit risk to the counties which are more exposed to heat risk. Now, of course, that's a hypothesis, and we can test it in data. Okay, so what do? We look at municipal bonds data. I won't get into the sample and so on, but roughly we look at the spread on a municipal bond of a county C. Of course, they may have many different kinds of bonds of different maturities and so on. So we basically allow for spreads to fluctuate by some time fixed effect, the spreads on a given county to basically have some average borrowing cost. But we control in the variable Z over there what's the credit rating of the county, and we allow for each credit rating to contribute differently to the credit spread in a given year. And after controlling for all of these things, we ask if a county has a high physical risk as per the C-glass measure, will it have a higher credit risk? Okay, so if in the cross section of municipal bonds, after controlling for credit risk, after controlling for a time fixed effect, and after controlling for a county fixed effect over the entire period, in a given year, if a hotter county is showing up as higher spreads of borrowing than a cooler county, then we'll pick that up as the pricing of heat stress risk in our data. Okay, so what does that look like? You can see that on the left, that since 2012, there is about 25 to 30 basis points extra borrowing cost as a function of this risk measure. So 1% of GDP economic damage attributable to heat stress risk in the C-glass method contributes to about 25 to 30 basis points extra. Now, what's interesting is that these effects are stronger for lower rated municipalities because a given impact on cash flows should impact a worse credit rating company or a municipality more. Climate risk is priced more in longer term bonds. There is not much of an impact on shorter term bonds at all. And there are two types of municipal bonds in the US. One is called revenue bonds. So think about a utility issuing a bond and then saying only the utility fees that I charge the consumers, I can pay the bonds only out of those fees. Or if you have a tollway that's collecting tolls, a utility will pay only out of the tolls that it's collecting rather than some broader taxes. Another kind of bonds are general obligation bonds, in which the municipality is collecting taxes across the entire coverage of the municipality, and then it can use all of these taxes actually to make the payments. So clearly, where you can collect taxes, there is greater strength in the bonds, and you find that bulk of the climate change effects is in the pricing of revenue-only bonds, like bonds of utilities, for example. Okay. And all of the components of economic damages matter, especially energy expenditures and the high-risk labor components. Okay. Next, you can look at corporate bonds data and you find a very similar result. We use the same methodology, spread on bond B of a company I. We once again have company fixed effects, time fixed effects, and we control for a credit rating time fixed effect. and then we check whether the 427 score, heat score of the company, leads to a higher credit spread or not. And once again, we find a similar result. In investment grade companies, there is no impact of climate risk, heat stress risk on the pricing of the bonds. In contrast, for junk bonds, the heat stress is priced on the order of 30 to 50 basis points per annum. And you can see again that these effects are more stronger from 2010, 11, 12 onwards, maybe because of attention or because of pricing of heat stress risk. Finally, I think I'll skip some of the other results. We also look at expected returns on equities of these S&P 500 companies. To get at this, we use a particular measure to extract expected returns at each year. And then what do? We basically run a very similar type of expected returns analysis for a company I at time t, and see whether, after controlling for company and time fixed effects, the cost of capital unlevered for equities is linked to the 427 score. And we find again that companies are paying about 45 to 50 basis points per annum extra if they are exposed to more heat stress risk through their locations. Okay. So let me stop there. A big question that we are not answering is there adaptation? As heat stress is increasing, are companies moving their staff and location of plants away from hot areas into cooler areas? Okay. Now that's going to work against us finding any impact on higher cost, because if you can always adapt and never be exposed to heat stress risk, the market should not actually be penalizing companies for heat stress risk. Now, of course, it may not be that easy to do. Migrating labor, migrating plants may take some time. Second, municipalities, of course, cannot migrate, other than moving entirely altogether, and maybe they become so unimportant that they won't be in the municipal bond market in the first place. But we think these adaptations are likely to be over a period of time. We are looking mostly at 10-year, up to 10-year bonds, and maybe some of the adaptations might happen at a much higher frequency. And so that's a question that remains to be thought of and factored into as one does this. Okay, so let me stop there. Essentially, what I want to convey to you is that heat stress can be measured. There are interesting ways of projecting global stress scenarios and then mapping those into regional stress scenarios. And then you can convert the regional stress scenarios into economic damages. For example, I would love to be able to do how much does Delhi spend extra on energy consumption when the summer is hotter by 1 degree Celsius. I think that's a very quantifiable question that one can ask. And I think if one can do that, then I think one can start talking about seeing the impact of all this on businesses that are located in Delhi and so on. It seems from the United States data that heat stress is priced. Companies and municipalities that are exposed to heat stress are recognized as having worse cash flows, and cash flows that are going to be bad when the global economy is suffering, and therefore they have to pay higher expected return to investors for bearing this risk. My sense is that heat stress is really now very tangible. It perhaps was something that seemed like a thing of the future 20 years back when the term global warming really hit the center stage. But now it feels very, very palpable. Financial Times actually ran a documentary on India's exposure to heat stress risk. If you have not seen it, I very highly recommend it. It had contributions in form of interviews of workers, interviews of NGOs, which are actually trying to escalate the cause of climate change in India to government and other agencies. But essentially, you can immediately see that conditions for many workers in India will be far worse than they are in United States, where overall level of wealth and income are much higher, access to air conditioning in all kinds of locations is much easier than it is in many, many parts of India. Let me stop there. Thank you, sir.
Thank you, sir, for the keynote address on unique concept of heat stress risk and its relation with economic damages.
Now it's time for the members of the audience who have any questions to pose the same.
Hello, good morning, everyone. My name is Surya Jirigunta. I run a EV startup and a BRICS Chamber of Commerce energy convener. Fantastic presentation from the speakers. I mean, I really enjoyed thoroughly both the speakers. And I have two questions. One for Viral Acharya ji. You have this RCP model, right? And then you basically get down deeper into the per each city. Do you factor in the local factors like the local cities adopting to renewable energy, electric vehicles? So how do those factors factor in this kind of modeling in the risk analysis? That is my first question. And sir, regarding the independent directors, the requirement of focusing on these related party transactions and sustainability. The Institute of ISCA has started this independence data bank, but somehow we are not able to. The SEBI is not able to utilize the the data bank and the independent directors that are being generated from this data bank. So how can we utilize the skill sets of the independent directors and make sure we fill in all the vacant posts that are available in all these various sectors? These are the two questions. Thank you.
Yeah, I think so. This issue of mitigation or adaptation is very, very important. As I was saying, at least as far as the research goes, it almost works against actually finding any effects, because if all of climate risk is going to be adapted perfectly by a region that's hot compared so that it behaves exactly the same way as a region that's not so hot, then of course there won't be any impact. But I think as Sir was saying, mitigation adaptation is costly in the short run. And it'll be costly for municipalities, it'll be costly for companies. And so perhaps the markets are saying that even if there is going to be adaptation possible, it's not a costless transition. Maybe you come to a better point, but you still have to incur some costs along the way of doing this. Now, maybe something like electrical vehicles is a relatively maybe more easier transition in some sense, because it's just a replenishing of the inventory as it ages. But I can see that for many companies it would mean a fundamentally different business model, and then they have to evaluate their sort of efficiency or profitability objectives against the impact that the market is going to charge if you don't adapt it. So I think it's a very longish answer, but I think it's an important question. You can actually do some interesting analysis. We've just started. So, for example, suppose you have every year a company's footprint in different regions. So, what are the plants it has? What is the distribution of its labor across these plants? What sales is it generating in different geographies? And you can ask an adaptation question. Are companies moving away from Delhi because it's too hot and they can't have a pleasant summer for their employees? If yes, where are they going? Are they going into regions where maybe the issues are not as bad in the summers, for example? Are farming companies moving away from areas where groundwater drought issues are very severe? Where are they going? Are they going into regions where it is not as severe? So if one has this sort of a time series data, one can ask these questions. And it's possible that the pricing of climate risk in the markets over the last 10 years would be one of the incentives to actually do some adaptation and mitigation. It could be the activism of ESG investors, maybe of entities like SEBI requiring disclosures, and then disclosures in turn giving rise to activism. So I'm sort of broadly agreeing with you that mitigation, adaptation is a very interesting exercise to study, but it requires some time series data on behavior of companies, behavior of municipalities, and then one can see what they are doing. Is it having some material impact in keeping their costs of borrowing low? But I have no doubt that we will adapt and we will mitigate. The question is how much is consistent with shareholder value maximization, giving activism of various types of investors and your labor along the way.
So, I think, just coming to your question on independent directors, I would say that movement has started. So, first is investors and stakeholders asking the right question: that why is somebody a director? What is the contribution? Is he or she adding value in the area that you expect them to? If not, SEBI is now forcing reappointment to happen, every 5 years, or there's a requirement. And there is, shareholder protests. There are, resolutions which are not getting voted. There are enough examples where directors have not been voted. So, I think it's a movement. It's going to take time. Unfortunately, it's going to take time. But I would say that we are seeing the movement already showing some action. And you are seeing boards, having a dialogue. NRC is accountable. They're asking to, like I said, are you having the right skill set? Are we covering all the skills required for the company? Like for a BFSI company, technology is very important given the cyber risk. So they're asking who in the board understands technology, or are we all banking professionals who understand banking well but no exposure to technology? Shouldn't we diversify? Shouldn't we get that caliber so that that person can ask the right question and help the bank and the company go up that curve? I think these are the discussions which are going to start helping improve, which means there will be a lot more requirement of independent directors with caliber, with capability, and I think that's an opportunity for many people.
Good morning. I'm Dr. Taufik Ahmed Siddiqui from Department of Management Studies, Jamia Millia Islamia. Sir, actually my question is simple. That, for example, in NSE, several indices are there. Now, in like other theme-based indices, NSE indices are also there. ESG indices are also there. So if I'm going to buy a share, if that share is listed in ESG indices or not, how does it impact me? Because for an investor, obviously profit is important. So so this is this simply I want to know.
I think this is the question I said as a human being we have to ask each other.
No, but
Is
for
it
investor,
only for us? No.
For investor.
I think ultimately you are a human, right? Even if you are investor, if you're only looking at short-term profit, and that's the dilemma that companies are facing.
Yes.
As a CEO of the company, I can say that I can go out and say, listen, I need to invest X for going on this journey, which means my return will be lower by X percentage for the next 2, 3, 4 years. But over a period of time, this is what it is going to help from an organization longer term sustainability. Now, if the stakeholders who are funding me don't agree with that, then it will be very difficult for me to take that journey in that organization. So I think, that is why I'm appealing to the human side. It is a dilemma which each one of us have to handle.
But sir, how investors can be appealed? Because for them, profit is important.
No, so
as human beings, that is
it's about
right
longevity and consistent returns over a period of time. If you're only looking at 1 year return, then like I said, if tech company is not doing well today, you will go from tech to energy company. But if you're looking at longevity of consistent profits, you're going to start looking at sectors and saying within those sectors, companies which are going to protect your capital, which are going to give you better returns over a period of time, and that is where sustainability comes in.
Okay. Thank you, sir.
Unfortunately, due to paucity of time, we'll not be going ahead with the question answer session. Thank you so much, sir, for the enlightening session.
We have prepared a research compendium of the papers selected for the conference. As Mr. CKG Nair said, we have received a total of 147 papers, and after a rigorous process of review, a total of 20 abstracts and 9 full research papers are published in the compendium. I would now request the distinguished dignitaries on the dais to please come forward and launch the research compendium. Now I request our director, Mr. CKG Nair, to hand over a token of appreciation to Mr. Viral Acharya. Now I request Dr. Kevin R. James to hand over the token of appreciation to Mr. Amish Mehta.
Now it's the time for the vote of thanks. Now I request Dr. Kevin R. James to deliver the vote of thanks. Dr. James is an economist in the Systemic Risk Center at London School of Economics and a blogger for the Times of India. His research focuses upon the relationship between financial market effectiveness, regulation and economic performance, systemic risk modeling, and corporate finance. Sir, now please request you to deliver the vote of thanks.
Thank you. So on behalf of the Systemic Risk Center at the London School of Economics, I'd like to thank you all for coming to our conference. Financial markets are going to play a crucial role in determining the effective economic future of the world, in the UK, the US, and India. And so it's great that we have this conference where we can focus on how we can improve the ability of financial markets to serve the real economy. This conference is only possible because of the hard work of the people at NISM. So I'd like to thank sort of the director of NISM, the registrar, and the administration for sort of going along with this conference idea and supporting the event. And then the sort of NISM staff for making it all possible. So including, all the different departments, the IT department, the APU department, the staff of the GST department, the caterers, security, all these people who have made this whole event possible. And these all creates a stage, but of course, the conference itself is going to be determined by all of us, who are here participating. So I'd like to thank all the people who are presenting papers that we can all enjoy, and session chairs and discussants who are going to make the sessions worthwhile. And then, of course, our distinguished guest speakers for presenting sort of lectures from the cutting edge of academia. So that's it. So thank you, and now we can start. Let's have a fun conference. Thank you.
Thank you, sir.
We once again thank all the dignitaries on the dais and all the participants for their presence for the conference. We wish you all fulfilling and enriching experiences at the conference.
Thank you all.